I'll now be working on deformation for an apex rig. The deformation that I'm going to be setting up is actually reasonably complex, although it is one of the most common and useful forms of deformation. I'm going to be performing lattice deformation, and despite the fact that this is a very common form of deformation, it is very tricky to set up. So what I'm going to be working on is this eye geometry, and I'm going to perform a lattice deformation on this eye. Lattice deformations are very useful for cartoon style rigs, or characters that are flexible and require a lot of deformation. Lattice rig setups can become incredibly complex, but they do give you a lot of flexibility. So now look at the rig which I've already got set up. Initially I have my geometry for the eye, in this case I'm just using a sphere. I then have two color nodes which are giving some color to the eye. This will actually make it easier to identify what is happening with the sphere. I then have created a very basic rig, and this is a 2-bone rig. Essentially I have a bone for the head and I have a bone for the eye. I'm creating this with a 3-bone skeleton though. The reason I have an extra bone is to allow me to get a better orientation, and here I'm generating the orientation using an orient joints node. After this I'll delete the final joint as this is not needed for deformation. I'm then adding weights to the mesh with a capture joint by a harmonic node, and this will allow us to deform the mesh. This is followed by 2 nulls which I'm using for outputs. These nulls will be used to reference the geometry within the apex rig, and this is what will be used to create the packed geometry. This is followed by a bone deformation node, and this is purely for testing. I'm then referencing the 2 nulls in object merge nodes, and this is where I'll create the packed geometry for the apex rig. Before I do that, however, I will need to create a lattice setup, and for this I'm going to duplicate the merge node for the mesh. This will give me the geometry for the eye, and I'm going to deform this with a lattice. For this I'll require 2 nodes. The main one will be the lattice node, and this is what will create the deformation. This will not actually be necessary for the apex rig, but it will allow us to visualize the creation of the original deformation. Next we'll create the actual lattice for the deformation, and this will be created with the bound node. The bound node will have its input set by our mesh, and its output will set the second and the third port for the lattice node. By default this is creating a bounding box. In order for this to work as lattice I'll need to activate the divisions. In this case we'll have divisions along the X, Y and Z axis. All of these divisions will have 3 as the default value. These divisions will be mirrored by divisions within the lattice node itself, and the divisions of the lattice which we're generating must match the divisions within the lattice node. So if I set the lattice node to have divisions of 4 in all the axes, I'll get an error as these no longer match. And to get these to work in, I'll need to update the divisions in the bounds, which I'll now all update to have the value of 4 as well. Generally when working with the lattice you want to keep the divisions lower, as you want to have a minimal cage for the deformation. However, this will always be very situational. So this will give me the lattice setup, but in order for this to work I will actually need to modify the lattice. The first connection is the rest lattice, which will be the unchanged version of the lattice, and the second branch for the lattice will be modified. There is however a caveat for this. At the time I'm making this video there are limitations on how we can modify this geometry. Typically there are 3 main nodes which I would use to modify geometry. The first of these will be the sculpt node, however I will not actually recommend trying to use this with the bounds at the moment. At the time when I'm recording this there is a bug with this node, which could lead to Houdini crashing if you try and use it with the lattice. So this may well be fixed within the future, but for the moment this node will not work well with the lattice. The main node that I'll use in this case would be the edit node, although you can also technically use the polydraw node. The polydraw node is a version of the topo build tool. We will be able to manipulate our mesh with this. There are some issues however with the polydraw node, in that the fall off does not work particularly well, as the polydraw node is actually designed to work with surfaces and it doesn't deal with the volumes particularly well. So you can manipulate the mesh with it, but it's not particularly effective. So next we'll deal with the edit node. For the edit node the main fall off will be set by the radius. To do this I'm going to select the face points along the Z axis. I'll drag them forward in Z, and here I'll be able to increase the fall off radius, and here I have activated the visualizations for this, so we should be able to see how the fall off affects the mesh. We should now be able to see the final deformation, and we should be able to see how the lattice is affecting the eye. I'll rename the node where I'm editing the lattice, and I'll give this a name of Z. This is not a particularly good name, but it will work for this example. I can then get a second edit node. I do want to create a number of shapes so we can blend between them, as this will make it easier to test if the lattice is working correctly. So I'm going to make a deformation along the y-axis to go along with my deformation along the z-axis. I'll restrict the changes to this node. I'll then select all of the face points at the top of the lattice. These points can be raised in the y-axis. I'll name this edit node Y. I'll then want 2 more edit nodes, and these will be called SZ and SY. I'll reset the animation on these edit nodes. For the SZ, I'll select all of the points, and then I'll scale these points along the Z-axis. For the SY, I'll also select all of the points, and I'll scale these along the Y-axis. So this should give me some shapes to test with. I want to be able to test that all these shapes work with my lattice. So I'm going to store this, and to do this I'll get a blend shapes node. All of the shapes will be connected to the second input of the blend shapes node. I'll connect the original bounce geometry to the first input. The blend shapes node will then set the third port of the lattice node, and in the blend shape node itself I can create all the blend shapes. This will be done with the update channel names from inputs button. All the shapes will now have names based off the node names. I can then use the controls to blend between my lattice deformations. So that will give me my lattice and it will give me some basic deformation. This, however, will not work with Apex and it will not work with KineFX. So I will need to convert these to attribute-based shapes in order to work with them correctly. To do this, I'll use a character blend shapes add node. The first input of this node will be set by the geometry which is going to be storing the blend shapes. And in this case, the geometry is created by the bounds node. As soon as I connect this though, I will get a warning. And that's because the geometry which I'm making the blend shapes on should have name attribute. So I'm going to add the name attribute, and I'll add this with the name node, and the name will be a primitive attribute. The name node will be connected directly after I create my bounds, so I'll connect all the wires coming out of the bound to the output for the name, and its input will be connected to the bounds node. This will be a primitive name, and the name will be Lattice. The next thing that I need to do is convert the shapes into packed geometry. I'll select all of the shapes, and I'll merge them with the merge packed node. I'll make sure that all the names are correct in the merge packed node. The names will generally be based off the inputs. I can rename them if necessary, but these names should be correct for now. This will be connected to the second input of the character blend shapes add node. The character blend shapes will now be added to the geometry, and I can end this network off with a null. I'll call this null Lattice. So I have now created the iRig and the lattice geometry, and I'll want to use these within the Apex rig. However, to do this I will need one more value, and this value will be used to drive the shape deformation within the Apex network. I'm going to place this value on my skeleton. I couldn't make a specific skeletal structure for the lattice, but this should work when placed on the original rig skeleton, so I'll do that as it is neater. I'm going to add this with an attribute wrangle node, and I'm going to do this after I've added the weights to the character. In this case, I'll run a script which will add these procedurally based off the attributes on the merge packed node. I'll need a reference for my merge packed node, and I'll do this within a spare input. I'll need to know how many primitives we're running over. I'll store this in a float variable, and this should be called prims, although this should actually be an integer and not a float. I'll get the primitives with an endPrimitives function. I'll get this from the spare input using -1. I can now loop over the primitives. For int I equals 0, I is less than prims, I++. I now want a way in which to identify the shape names. And the easiest way to do this off the merge packed node will be to look at the primitive attributes, and the attribute that I'll be looking for here will be name. So I'll store this attribute in a string variable, and this variable will be called name. This will be a primitive attribute, so I'll use the prim function. I'll get this from my spare input with -1. The name of this attribute is name. The primitive number will be specified by the index of the for loop, and this will be I. I can now create the detail attribute. I'll do this using the setDetailAttribute function. This will be created on my current geometry, so it will be created on input 0. The name of the attribute will be specified by the name variable, and I want this to have a float value, so it will have a value of 0.0. I can now test to see if this is working. We'll look for the attributes in the geometry spreadsheet, and these attributes will be under the detail attributes. I should have 4 attributes here, and all of these should have a value of 0. I can now begin working on the Apex rig, and for the Apex rig I want a reference to the lattice geometry. To do this, I'll duplicate one of my object merge nodes. This node will be renamed to merge lattice, and here I'll refer to the lattice null, and this is what's capping off the lattice network. So this should give us what we need for the rig. However, this will not actually work, and there will be more that we need to add, but we'll look at that later. I can now start making the rig, and for this I'll need a packed folder, and I'm going to connect all of my merge nodes to the second input of the packed folder. I'll then need to rename the elements of the rig. The first of these will be for the mesh, and I'll give this the default name of base, and I'll specify that this is a mesh by giving it the type shape. The next element will be for our lattice geometry, and this will also be a mesh, so I'll give this the name lattice and the type shape. The third input will be my skeleton. This will have the type skeleton. This will give me the geometry I need, but I also need a graph, and for this I'll get an Apex Edit Graph node. I'll connect this to the second input as well, but I will reorder this so that this is the first input of the rig. I'll give this a default name, which will be base.rig. This will give me my packed geometry setup, and I can now work on the graph. I will change the layout to something a little bit more appropriate. The graph will need an input node and an output node. I can now start making connections, and the first connection that I'll make will be for the base mesh. This will be specified by renaming the port to base.shape. This will give me a neutral port type, but I want this to be geometry. For the moment, I'll force this by getting a value geometry node, and I'm going to connect this to the inputs. The output port will specify my final geometry, and this should also be renamed to base.shape. This will pass through my mesh geometry, and there's nothing particularly complicated about this. If I activate the state, I should see that my eye is showing, and I should have nothing else showing. Next, I can add a reference to the lattice. I am going to pass the lattice out of this network, although that is going to be primarily for visualization, as I do not actually need to see the lattice for the final animation. I'll call the input lattice.shape. I will also name the output lattice.shape. If I activate my animation state, we should now see that the lattice is showing. The final piece of geometry that I'm going to use is not going to be an output. This geometry will only be used for information within this setup, and this port will be for our skeleton. I'll call the input base.skull, and this should refer to the skeleton. The skeleton is going to be used to control the detail attributes, and I'm going to control these using abstract controls. I have 4 shapes, so I'll need 4 abstract controls. I want to organize these controls within the scene. To do this, I will update the matrices. I'll begin by setting this as an identity matrix. I'm then going to offset it in the x-axis. I'll do the same for the second control. However, this one will also be offset in the y-axis. This pattern will continue for all of these controls, where these all have an offset of x and have an increase of 0.1 for each y offset. All of these currently have a 0 value, but for testing values, I'll change these to all have a default value which is somewhere in between 0 and 1. All of the abstract controls will need to have their exports imposed in the input node. I am not currently going to rename any of these ports. I should now have my controls exposed. I can test this, and I should see my controls in the viewport, and each of them should be separated from each other. I will of course need to make sure that they all have the same x value. So these will allow me to manipulate my detail attributes, and in the Apex graph I'll be setting these with a set detail attribute value node, and this will be of type float. This is going to work on the skeleton geometry, so I'll connect the skeleton input to the geometry input. I have 4 shapes, so I'll need 4 copies of this node, and each of these should have the geometry ports set in series. The values for each of these nodes will be set with the respective abstract control node, where the value input port will be connected to the X output port. I can then specify the names of the attributes. I'll have the SZ attribute, followed by the SY attribute. I'll have the Y attribute, and finally I'll have the Z attribute. I now want to update the shapes in the lattice. For this I'm going to look for a node within the KineFX library, and here I'm going to be looking for the character blend shape core node. This node has 2 geometry ports. The second geometry port will take the geometry from the skeleton. The first geometry port is the geometry which we're going to deform, and the lattice is the method that is going to be driving this port. I do want to update the error reporting on the Apex Edit Graph node. I'm going to set this to report as warnings. I can then test to see if this is working. However, nothing is happening. This is actually due to my skeleton. My skeleton is currently connected to a value geometry node, but this should actually be connected directly to the setPoint transforms nodes. The updating of attributes on skeleton geometry generally does not work when the skeleton is cached via a value node. I should now be able to test the rig again. I now have my lattice deforming. This means that I can use this lattice to drive a deformation, and in this case it will be the deformation of the eye. To perform this deformation, I'm going to use a lattice node, and this will be found under the geometry library of Apex nodes. This means that this is not actually a soft verb, but instead is a deformer which is specifically part of the Apex setup. So this node has similarities to the lattice deformer, but it is not exactly the same, and this one actually has far less options. There are some parameters that we will need to update in this node, specifically the divisions, and these should match the divisions within the lattice. So in this case, all of these should be set to 4. I can connect this node now, and this node will have 3 geometry ports. The third port will be the deformed lattice, and this is what we'll use to give us the final deformation. The first port will be the geometry that we want to deform. The second port requires the lattice geometry but in a rest state, so the rest geometry for the lattice must not move. So I'm going to set this from the value node, where I will set the third port directly from the input. So this will complete the setup. However, when I reset the animation, nothing will happen. Now I cannot explain exactly why this happens, but Apex can be sensitive to geometry which is being modified, and what we need here is both modified geometry and static geometry. So it is actually very simple to fix this problem, but this problem is obscure and it's not particularly obvious when you're trying to work with the solver. So what I'm going to do is I'm going to duplicate the null which is ending the lattice network. I'm going to connect this null to my lattice geometry, but I'm going to do this before I add the shapes. So I'll connect this directly to the name node. I'll rename the null to lattice rest. I'm now going to reference this geometry for my rig as well. I'll duplicate the merge node for the lattice, and this will now reference the lattice rest node. I'll then reorganize my ports. I should now have an entry which I'm going to call lattice rest, and this will be of type shape. I can now use this within the network. In the input node, I'll add an extra input, and this will be called lattice rest.shape. This will be a geometry port. I do have a free value geometry node that I had when I generated the skeleton, and I'll enforce that this will be a geometry port by connecting this to the lattice rest port. I'll now use this lattice shape for the rest geometry within the lattice. This shape is a shape which will never be modified and will always act as a rest shape, and this change should fix my lattice. I have, however, made a naming mistake in the pack geometry. This should be lattice rest.shape, not lattice1. I should now have my lattice geometry deforming as expected. This will give us the basic lattice, and this will give us our basic deformation. So this is how we'll add a lattice to the rig using Apex, and we should now be able to use our rig to drive this deformation.